Hello all, myself Purnima, Professor in Department of ENCE, SVC Bangalore. Today we will be discussing about the microcontroller and my embedded systems. Coming to the topic of today is Introduction to Embedded System. The main objective of this lecture is to understand the embedded system, how basically the embedded system will be defining, and what are the embedded systems which are available, that is through the classification. Once we learn, at the end of this lecture, we are able to define embedded system and classify the various embedded systems. When we go for the definition of this embedded system, the embedded system is defined as the combination of hardware as well as the software. So both hardware and the software it will have on an embedded system. So combining the hardware and the software for the purpose to perform a specific job. And that is the basic definition of an embedded system. In simple terms, the embedded system is defined as a computer which will have the both hardware and the software related to a specific job to perform. The embedded software which is placed in embedded system executes a specific job. So it is also termed to be a firmware. If you look at this embedded system application, it is used in almost all fields of the consumer, where the consumer electronics, it will be used in food processing industries, chemical plants, cement plants, biomedical equipments. It includes telecommunication industries, then along with the security systems also. Now let us see how this basic embedded system which has been built. This is a block diagram which represents the basic building block of an embedded system. In the real world, the embedded system consists of the 6 major components, which includes a system core, the memory, communication interfaces, input ports, output ports, and other supporting integrated circuits. This embedded system, as we already know that it does a specific job, hence it is a dedicated computer-based system for a specific application. The software which is going to be embedded on this embedded system will be stored in an read-only memory. It is also termed as the ROM. So ROM will have the the firmware which is getting stored. That program will, or that software will tell the embedded system what specific job it has to do. Apart from that, the hardware, when you look at this embedded system, the hardware consists of 6 main components. It is the first one, if you take, it is an CPU, central processing unit. You can see the memory. It can be an RAM or it can be the ROM. The memory will have both the RAM and ROM together for any of the microcontroller based embedded system or microprocessor based embedded system. Apart from this, the next block you can see is an input unit and then output unit, application specific circuitry, and communication interfaces. So the central processing unit, what it does, it does the arithmetic and logical operations. So this central processing unit will have the three different blocks. One is ALU, the control unit, and register set. So with the help of this arithmetic logical unit, the CPU is able to perform arithmetic operations as well as the logical operations. When you look at this arithmetic operations, it includes the addition, subtraction, multiplication, division, and so on. If the logical operations are considered AND, OR, XOR, etc., the memory of an embedded system typically will be of the read-only memory, that is a non-volatile memory, and the RAM, non-volatile memory. This RAM will act as user scratch pad, and if you look at the ROM, it is a permanent memory, and this permanent memory which is used for the firmware to store. The input unit, it is used in an embedded system to give the inputs. The inputs, whenever it has to be, or the instructions has to be given to an embedded system, the input devices will be used. One best example for this is a keypad. Other examples, if you look at, it can be an mouse, joystick, etc. These are all the various important input devices which can be used in an embedded system to input the data. Once the specific task has been done by the embedded system, the output has to be displayed. So for that, there is an output unit associated with this embedded system. These output devices includes the LCD, it may be an LED display, or it may be an CRT display, or it may be an memory again. The memory, it also sometimes acts as the output unit whenever it has to be stored. If you go for the application specific circuitry, these are all the application specific, like AVR board, AVRs, etc. They are the application specific circuitries. And if the communication interfaces, because whenever the input device, which is the central processing unit, it is interacting with the input device to perform a specific task, it has to be sent to the output device. Thereby the communication interfaces, it will be such as ZigBee or your Wi-Fi. These are all the communication protocols, which interfaces which most of the embedded system will be having. So such embedded system communication interfaces are often used for communicating information. Now, the main important point here we have to discuss is how the core of the embedded system it is built. The core, that is the central processing unit of embedded system, falls in any one of these following categories. 4 categories we can see this slide. So those 4 categories it can fall. The first category, if you look at it, it may be the core may be the general purpose or domain specific or application specific processor, or the CPU or the core can be a general purpose processor or domain specific processor. The general purpose processor or embedded system in which the CPU or the core, it is built the using the microprocessor. When you look at these microprocessors, it can be an 8-bit or it can be 16-bit, 32-bit or 64-bit. The examples of these microprocessors when they are used in an embedded system, they can be 8085, 8086, or you can see 80186, 286, etc. Pentium 4, Pentium Core, all these are the examples of microprocessors. The various manufacturers, if you look at, they are from Intel, AMD, ARM, Fairchild, etc. The core can also be, whenever we go for the general purpose, it is the microprocessor as the core. But when you go for domain specific processors, the domain specific processors based on the core, which processor it is going to be used, they are domain specific. If the core is designed with the microcontrollers, then it is the domain specific or application specific. Again, here the microcontrollers can be of 8-bit processors or 16-bit microcontrollers or 32-bit microcontrollers. Examples you can look at here: MCS 51, MCS 96, and so on, 8-bit, 16-bit, and so on, which are available from various manufacturers with the different IC numbers. Again, here you can see the main manufacturers of microcontrollers are AMD, then Atmel, Intel, DEC, the Fairchild, etc. If the core is designed with another type of processor, that is the digital signal processors, then it is termed to be a domain specific processor core or domain specific embedded system. If the digital signal processor is used specifically to process these signals during that time, the core can be 8-bit or it can be the 16-bit, 32-bit or 64-bit. The examples you can look at here is the C6000 or TMS 320 C6474. Here also the core, if it is of digital signal processor, the manufacturer for this digital signal processor core is, it can be Texas or it can be used from Texas manufacturer or Freescale or Analog Device, NXP or Microchip A. Based on the embedded system core, if the core can also be designed using another type of device, it is the programmable logic device. It is also in short term to be the programmable logic devices. The core of an embedded system, even it can be of application specific integrated circuits. So ASICs also. The another type of embedded system which is available is the commercial off the shelf components. So now let us see what is the difference between the general purpose processor and the application specific instruction set processors. The general purpose processors are, it is also termed to be the GPP. It is a processor designed to perform general computational tasks. These general purpose processors, when they are used in embedded system, these GPPs are produced in large volumes, and these general purpose processors targets the general market. So whenever these general purpose processors are in production or in fabrication, high volumes will be produced, and the unit per cost of for a chip is very low compared to the application specific or any other specific integrated circuits. The general purpose processor usually will have arithmetic and logical unit and the control unit. The application specific instructions processors are the processors with the architecture and instructions both are optimized to specific domain or specific application requirements. Like this application specific instruction set processors are used in network processing, automotive electronics, telecommunication, media applications, digital signal processing, control applications. The application specific instruction set processors, they are the spectrum occupied between the general purpose processors and the application specific integrated circuits. These ASIPs are derived from the general purpose processors, but whenever general purpose processor is unable to meet the increasing application needs, so during that time these general purpose processors have been converted into application specific instruction set processors. Some of the microcontrollers which we will see in our day-to-day activities are AVR, USB AVR from Atmel, system on chips, digital signal processors are the examples. These application specific instruction set processors incorporates a processor and on-chip peripherals which are demanded by the application requirement, program and data memory. So we will be continuing further related to this embedded system in the next lecture series. Thank you.